At an air show, a jet flies directly toward the stands at a speed of 1,200 kilometers per hour, emitting a frequency of 3,500 hertz on a day when the speed of sound is 342 meters per second. What frequency is received by the observers? What frequency do they receive as the plane flies directly away from them? Okay, so here's a Doppler effect problem, and the perceived frequency is speed of sound divided by the speed of observer, and v minus speed of source times the emitted frequency. And the sign convention is if the observer is moving towards the source, that would be positive. That speed would be positive. If the source is moving towards the observer, that speed would be positive, and negative otherwise. Okay, so that's the sign convention. Okay, so the speed of the plane, which is the source, is 1200 kilometers per hour, and we'll convert this to meters per second. 1200 into 10 to the 3 meters, and 1 hour is 3,600 seconds. So the speed is 333.3 meters per second. Okay, so in part A, the observer is at rest. Okay, so in both parts actually the observer is at rest, and so here's the observer and here's the source, and the source is moving towards the observer, so the source speed is positive. So the perceived frequency is the speed of sound plus speed of sound minus 333 meters per second times that. And the speed of sound that day is 342 meters per second. And actually, I won't write units because it gets messy. 342 minus 333.3, and so the emitted frequency is 3,500 hertz. And so this works out to so 1.38 into 10 to the 5 hertz. Okay, so that's the perceived frequency, and that's beyond our audible range, and so we shouldn't hear the plane coming. Okay, so for that particular frequency, of course, the low frequency sounds will get Doppler shifted to high pitches, so this particular frequency won't be heard, but other frequencies will be heard. Okay, now for part B, the plane has passed us, so let's calculate the frequency we'll hear for that particular frequency. So let's do a diagram. So now the source is moving away from us, and here we are, the observer. So f prime is v plus v0 minus v minus vs times this. Okay, 342 v0 is 0, and 342. Now this time the source is moving away, so the speed is negative. I mean, its velocity will be negative, so It's minus of minus 333.3 meters per second times 3,500 hertz. So this is 342 divided by 675.3 times 3. Okay. And so okay, so as the source moves away from the observer, the frequency is Doppler shifted downwards, as we know. So the pitch is lower. Okay, that finishes that problem.